This is a typical assembly language program. After completion of coding the assembly language program, one would assemble the program. The function of the assembling is to convert the assembly language program to machine codes. We would normally present the machine codes in hex numbers rather than binary for ease of reading. We normally refer machine codes as hex codes. The hex codes are eventually downloaded to the microcontroller program memory. Let's take a closer look at the assembly language program. These are the corresponding machine codes. For example, the machine codes for the assembly language instruction ljump main is 020100. The machine code for the assembly language instruction move hex A0 to SP is 7581A0. This is a typical representation of a 4 KB program memory. The machine codes are downloaded to the program memory. The codes 020100 are allocated here. The codes 7581A0 are allocated here. Why are the codes allocated in this manner? The origin 000 hex directive dictates that the following machine code is allocated to program memory location 0000 hex. Therefore, codes 020100 are allocated to program memory locations starting at 0000 hex. 02 hex is stored in location 000. 01 hex is stored in location 0001. 00 is stored in location 0002. Why can't the codes 020100 be all stored in location 0000 hex? Each memory location can only store 8 bits of data. The binary value of 02 hex is 00000010. Its size is 8 bits. Therefore, no more data can be stored in location 0000. The codes 7581A0 are stored starting at location 0100. This is so because of the origin 0100 directive just before the instruction. Where are the codes 7401 stored? The codes preceding this is 7581A0. Therefore, the codes 7401 are stored in the next available locations. The codes 020100 hex are stored starting at program memory location 000 hex. Let's write down the address 0000 hex. The codes 7581A0 are stored starting at program location 0100 hex. The codes 7401 are stored from location 0103 hex. What about the codes F590? This code will be stored just after the codes 7401. These are where 7401 are stored. The next available location is 0105 hex. Therefore, codes F590 are stored starting at location 0105 hex. What about the rest of the codes? Where are they stored? F5 is stored in 0105 hex. 90 is stored in the next location, which is 0106 hex. 23 is stored in the next location, which is 0107 hex. 12 is stored in 0108. 01 is stored in 0109. 0D is stored in 010A. Remember, in hex counting, the number after 9 is A. 80 is stored in 010B. FA is stored in 010C. 7E is stored in 010D. F0 is stored in 010E. 7F is stored in 010F. One zero is stored in 0110. DF is stored in 0111. EF is stored in 0112. DE is stored in 0113. FA is stored in 0114. 22 is stored in 0115. Let's rearrange this. This representation is what we call the assembly listing. The assembly listing shows the assembly language instructions, its corresponding machine codes, and the code locations where these codes are stored.